Hey everyone. In this video, we're going to take a look at how to simplify radicals containing imaginary numbers. Now, complex numbers are based on the imaginary number I, okay, and I is what's used to represent this right here, which is the square root of -1, which is an imaginary number. Okay, also another thing to note here, I squared, we can take the square of that I, is -1, which becomes important in some of the following lessons that we're going to talk about. All right, so let's take a look at how to actually simplify to get I. Okay, so when you're simplifying the radicals, you simplify them just as we've done in the past. Okay, you're going to break them into multiples. Okay, so -25, we want to look for perfect squares. 25 is already a perfect square, so I do not have to break that apart. And -1. Okay, I'm going to show each step this time. So we have the square root of 25 and we have the square root of -1. Okay, so the square root of 25 is 5. And now here we have our imaginary piece, which is the square root of -1, which is going to become an I in our answer. Okay, so again, just simplify, break it apart into your multiples, and solve. Okay, let's take a look at a couple more examples. Okay, so the first one, we have the square root of -4, very similar to the one we just talked about. This one, 4 is already a perfect square, so when I break this apart, I'll break it into 4 and -1. Okay, so the square root of 4 we know is 2, and the square root of -1 we know is now I. So it would be 2I is our final answer. Now, -32, 32 is not a perfect square, so we could break that into multiples. Okay, so let's go ahead and break that into 16 and 2. 16 being our greatest perfect square. And we also have the multiple -1. Okay, so again, let's go piece by piece here. The square root of 16 we know is 4. 2 does not have a square root, so that's going to stay underneath our radical as the square root of 2. And we know the square root of -1 is I, so we're going to go ahead and put an I here. Okay, so we have 4I square root of 2, and that would be our final answer for this one. All right, moving on. Okay, here we have negative and then the square root of -20. That negative's on the outside. Okay, so we're just focusing on breaking apart that -20. We could break that into, let's use the perfect square, 4 times 5, and again, -1. Okay, so again, that 20 broke into 4 times 5. You want one of your multiples to be the greatest perfect square. So in this case, it's 4. Okay, simplify that negative on the outside. The square root of 4 is 2. The square root of -1 is I. And the only thing that remains is that 5 because that does not have a perfect square. So solution to this one, 2I square root of 5. Sorry, -2I square root of 5. And in the last one, this is the complex number form, which is in the form A plus BI. Okay, and our second piece is going to be our imaginary part. So again, the 3 stays exactly as is. Okay, and now the square root of -9, we know we can break that -9 into 9 times -1. 3 plus square root of 9 is 3, and the square root of -1 we know becomes our 3 plus 3I. Okay, so there's a couple more examples of being able to simplify radicals containing those imaginary numbers in the answer.